Hi, here's chapter 3 review. Um, I have got some questions on this chapter. Graphing involves a lot of steps, a lot of pieces. There's a lot of language in this chapter to hopefully get solid on. And we're going to touch graphing again in our new material when we get started on chapter 4 and stuff. Sometimes we'll get to chapter 8, which is going to be using everything from chapter 3 with some add-on stuff. So it's an important chapter to make sure that you have a pretty good understanding of. Um, so let's talk about this. I'm going to kind of leave this chapter contents open over here. Usually I have a full screen, but because I'm going to bounce around a little bit. They start out in chapter 3. They're talking about reading graphs and plotting, and basically they're just trying to illustrate that graphs are important tools to draw pictures of things, and we use graphs a lot. So they're going through bar graphs and stuff, and when they get creative on how they make the bars, like in this case, stacked money to represent some things. So you need to have some general ideas about how when we have a horizontal means like horizon means it runs this way, across the horizon in a sense. And vertical axis, are used, and it's really up to the author or who's trying to illustrate the data on how they're going to um, make these views, and hopefully, they're trying to illustrate a point with data of some type. So, that's all that first section's about mostly, is saying here's a graph, read it, give me some information off this graph to make sure you understand how to read things. Okay? Now, the next section we're going to start talking about special situations in algebra where we have something that graphs and it'll make a straight line, and they're called linear equations. And there's specific things that have to be there and or not be there for them to stay linear or do that. And when you think about a graph, it's a relationship between two values, really, in this case, and that's what we're going to look at with linear equations. There's, like if I have a situation with a rate or something like that, if I'm making $10 an hour, I could make a graph of what that would look like for the amount of hours that I work. So I could have my pay be plotted on this graph. So for every hour horizontally, right, I could go for, the first hour I'd make $10. So it would be a point of at 1 hour, then it would show in the vertical distance would be 10 up for that $10, and so on. So, and then 2 hours and 3 hours and 2.5 hours, there's actually some pay amount that will be for that, like $15. So they're they're talking about relationships between these two numbers, and they're going to make some rules about saying, well, we're going to have a lot of situations where we have these relationships that happen, and they're giving us examples of this. And then they say, hey, when I have something like this equation, y equals 2x plus 1, where this could be, say, my pay is I get $2 an hour plus $1 for showing up or something like that, right? Well, if I worked 5 hours, I'd make $11. In this case, you have 3, right? They put a 3 in for x, you get 2 times 3 is 6, plus 1 is 7. Okay? Pretty poor pay, but that works, right? And they say, well, there's a relationship between this x makes a certain y happen, and so on. And that's what solutions are to things. And actually, there has to be two values or two numbers that we're going to put in here that make this equation true. There's a relationship between those numbers. Say, well, I put x as 3. Hey, it makes this equation true when y is 7. But if I tried 3 and 8, it wouldn't work, because then I'd get 8 equals 7. That's not true. So the only two numbers that make this equation true are 3 and 7. And then they make a decision on ordered pairs. They say, well, we always, in this place where I have a way to represent these two values is ordered. It has to be in order or else it'd get confusing. So they say the first number is always going to be horizontal change. So in this case, which would be the x value here, right? In this case, if they put 0 in here, they're doing this one right here. If you put 0 in for x, you get 1 for y. So you'd have the ordered pairs 0, 1. If I put 3 in for x, I get 7 for y. So I go 3 over. That's a horizontal change from 0, a positive 3, which is 3 to the right. And then up is positive. For vertical change is the second number. Okay? And usually, because of the alphabet, x comes before y. They usually label the axes or these lines, really. Going back to number lines, we could, if I only had one variable, I'm kind of working on one number line here. I got 2, so I have a vertical distance represented. So this gives me a way to show a picture of this equation by looking at samples of ordered pairs to see if they work. In this case, all 3 of these worked. If I drew a line through all 3 points, every point on that line would be a solution to this equation. So if I took any one, if I took like 1 here, right? Notice where it looks like it intersects on this line that we would draw would be at the point 1, 3. Well, does it work? If I put 1 in for x, I get y equals 2 times 1 plus 1, which is 3. So the ordered pair, 1 is my horizontal distance and 3 is my vertical change from 0, which is up 3. Okay. Over here where I go to negative 3, they put negative 3 in here. That's a horizontal distance from 0 to the left of 3. Left of 0, excuse me, which is 3 left of that. You get to negative 3. And then I get a negative 5 for y, which is a down 5 from 0, and I get here. That ordered pairs work. Okay? That's all that is. There's nothing more complicated about this all. We're just drawing a picture of solutions to this this equation, excuse me. There's an equal sign. Okay? Remember that solutions make equations true. So they start telling us some stuff about solutions to equations in 2 variables and those kind of things. These boxes are good stuff to read. Remember, go for the concepts. What are they explaining? It really helps me when I think about why are they doing this. And it's like when every time I have a word problem or any kind of mathematical problem that I can draw a picture of what's going on. That's exactly the strategy you should use. Well, they're basically giving us a defined way to draw pictures of these things so we can illustrate and basically show solutions. And we need some rules about drawing pictures of infinity, right? So when we have a line, there's arrows on each side of that line. There's an infinity of solutions for that last equation we talked about. So they say, well, let's set up this coordinate plane and we'll make some rules on how we write these or draw these pictures. So we follow that. We say that the first number in this ordered pair, order matters, right, should be changed from 0 on a horizontal plane. And then the second number is vertical. If we had 3 dimensions, the third one would be depth, or coming from to and from you and stuff. And they talk about 3D things and all that kind of stuff, which in a entertainment deal is a simulation, a basically trick to make things look like they have depth to it, right? And they do that a lot of different ways with the 3D movies now. But there you have 3 dimensions, an X, a Y, and a Z, usually is the next letter in the alphabet, values that I can graph. So a lot of language around that, a lot of rules. So you need to learn the rules so when we get different situations, your picture is drawn the same way that other people draw the picture. So they go through some examples here of doing this with just saying, let's guess and check, really, or what we're doing. We're saying, well, let's make a little table, and we say, put values in for X and see what our Y's come out, and then they show the ordered pairs and so on. And we can graph on that. And they always, why do you think they pull out 3 points? Well, if I make an error, a math error, and one of these points is off, one of these ordered pairs is not right, I will not be able to draw a line through all 3 of them, and that would be an indicator, hey, something's wrong, because these are supposed to make a line. Okay? So they're going to give us, this is one way to graph, and then they're going to give us some more methods on how to graph, or what are possible to graph. This is probably the least used method, but it's easiest kind of to illustrate how ordered pairs work. They want you to look at this and say, yeah, this is how ordered pair work. They're going to talk about forms now. Forms are, well, when an equation kind of looks like this might be a good method to do this. And this is called standard form, where the x and the y are on the same side of the equal sign. So you end up with something like this. We have 4 times x plus 2 times y equals 12. If you put, it kind of fits that table we're talking about in a way, right? If I put 3 in for x and 0 in for y, does that work? Well, yeah. If I put 3 in for x, I get 4 times 3 is 12. Well, what do I need to add to 12 to get 12, right? Is 0. The only way I can get this expression here, 2y to 0, is make y 0, so 2 times 0 is 0, and so on. And they go through that. And then they say, well, what if I made the first one 0? I end up with 4 times 0, which is 0. So I end up with 2y equals 12. And they get into some situations where you can say, well, how would I solve for y? Most of you can guess and check on these simple ones, and you say, hey, it must be 6, right? 6 times 2 is 12. So later on, we're going to go back to solving equations and using the property of addition and multiplication and those kinds of things on equations, where you have to add the same thing or multiply the same thing on both sides to keep equivalent equations, or equations that have the same solution. Okay? So then they're going to go through, they'd go through some problems on this. And I just want to make sure I don't skip anything here. And they go through applications. We have a lot of things that happen linearly in our world. There's a lot of things that are pretty close to making a line that we can try to predict some things. There's a lot of people lose money on the stock market trying to make lines fit into things they're seeing, looking for patterns on the stock market, those kinds of things. So they can hopefully use it to predict some value, right? And that's what they're trying to illustrate here. There's real worlds and stuff like that. And the caution they do here is also there are other types of graphing that can occur. There's special unique situations. First of all, the x and the y's never have any exponents except 1. There's no absolute value stuff. Here's x's to the cube power. And they're showing some patterns that, hey, these are not linear equations. In other words, they do not graph a straight line. This is called a parabola. Looks like a V to me. I'm not sure what they call that. But here's a cube line, is this little S line. Okay. And there's an illustration talking about graphing calculators, which are useful tools. Now, when they go through that graphing, basically is kind of from standard form, and now they're going to talk about defining some other words. When they start defining words in algebra, that's important. And they're going to use them a lot. They're going to ask you questions. There's going to be test questions on what an intercept is and stuff like that. And intercepts are really intersections. And they're talking about a special type of intersection is where they cross either these axes, these parts of the horizontal line that we put in here, which is usually x, and the vertical line, which is usually a y line. And where we cross that, we call that, if it crosses the x-axis, it's called the x-intercept. And if it crosses the y-axis, it's called the y-intercept. Well, we're going to use these things for specific purposes. That's why they name that. Really no real world things that happen here. We're going to say things like, hey, I got this situation with pay and everything else. I wonder what the intercepts are. Probably not going to be something you pull out of a word problem. So guess what? They're going to use these tools to hopefully make it more efficient to graph linear equations. Okay, so they're introducing them basically a piece of a tool. We pulled a nail out of our toolbox, and they're describing this nail, and you're going like, wow, here's a nail. What would you ever do with that without a hammer? Well, we're going to get a hammer here in a bit and use these intercepts to do some problem solving with, or create graphs hopefully more easily. And that's when they start defining terms and those kinds of things. Well, they also use the intercepts in nonlinear equations too. So this parabola here, which has some equation with, in this case would be y squared equals something x plus 2 or something, or x plus 4 in this graph, something like that. Well, there's intercepts here. One is that it crosses the y-axis at 4, or at this point of 0, 4. And it crosses the x-axis at 2 places, in this case, negative 2, 0, and 2, 0. Now notice that every point on the x-axis, what is the y-coordinate? Every place on this, every point that I could grab or place on this line right here, what is the y coordinate? The second number in my ordered pair. It's always 0. So if I said, hey, what do x-intercepts always have for an ordered pair? And you'd say the second number is always 0, or the y coordinate is 0. Well, what about the y-axis? What is every point on the y-axis? Well, the x value is 0. It has to be to sit on this line, okay? And why I'm pointing this out is that's going to become important to think about when we're looking for intercepts. So if I want to find an intercept of this equation 2x plus 4y equals 20, well, if I want to know where it crosses the y-axis, what happens on every point that crosses the y-axis? The x value is 0. So I put 0 in for x. And I end up with 2 times 0 plus 4y equals 20. And I end up with 0 plus 4y, which is 4y, equals 20. Well, I can solve this equation by taking 1/4 times both sides, or dividing by 4. That's the same thing. And I end up with y equals 5. So what I found is an ordered pair. I found an ordered pair that happens to be the y-intercept because the x part of that ordered pair is 0. So I end up with the point 0, 5. That is the y-intercept. If I want to find the x-intercept, what is true about every point on the x-axis? Well, y is equal to 0. So I put 0 in for the y part of this equation, and I end up with 2x plus 4 times 0 equals 20. Well, in other words, 2x plus 0, which happens to be 2x because we have the property of 0, right? That tells us that if I have to have properties to do things in algebra. I just can't say, hey, 5 plus 0 is 5, and 6, I can't prove things that way just by repeating operations or expression simplification. We have to prove that and give us properties. And that's an important point I'll probably talk about a lot, is that we have rules that we're applying. It allows us to do things like the commutative property, which is actually change the order of with operations of addition and multiplication. Associative property, or the distributive properties. And what do? They actually allow us to override order of operations, which is, we have these rules too that are order of operations. It says that we have to do what's in grouping symbols first, then exponents, multiplication and division left to right. It doesn't mean that multiplication comes before division all the time. It's if those two operations are in a line, it goes left to right, and then addition, subtraction, left to right. Well, if I have these things going on with operations of addition and multiplication, I can change the order. I can group things differently. I can use the distributive property to override grouping symbols and all kinds of stuff. Same thing, even it's usually harder to think about with real simple processes like multiplication is 0 and adding 0. Okay, but they gave us some rules about that which are important. And please think about what are the rule am I applying? As you're doing assignments, if you think about what truly the rules are that are allowing me to solve this thing rather than some memorized process, you're going to be a lot more successful in algebra classes. Alright, so they go through some examples here trying to look for intercepts. But what they do is they say, well, here's the one we found these intercepts. Hey, we could use those two ordered pairs to graph my line, because those are going to be 2 points on this solution line. Remember, this is all the ordered pairs that make this true. In other words, I could take any ordered pair on this purple line right here, and that ordered pair, when I put the values in for the x and the y, I'll end up with something that is equal to 20. Okay? It becomes true. Like they talk about this 5, 2.5, and so on. Solutions make true equations. Okay? So by finding the intercepts, which is kind of easy when you think about it, I like multiplying by 0. It's a very easy thing to do. By finding intercepts, I can do some graphing. Okay? I can take those 2 points on each axis and then draw the line between them. And now they always talk about bringing in this third point, though. Is that if I make a mistake and say 20, 0 is my x-intercept, but I make a mistake and do a math there and I think that negative 20, 0 is my y-intercept, this line's going to be a whole different line. And if I take this checkpoint, I say, well, 4, negative 24 works in this equation too, but I made a mistake here. I'm going to go, hey, not all 3 points are on a line. So that third point is a very good check method to make sure you're on the right track. Then they talk about horizontal and vertical lines. And if I have this, it says graph y equals 3. If you think about that, it means that I have a constant of 0 times the x value. In other words, it doesn't matter what x value I have. In this case, I end up with this horizontal line of this. And what is true on this line? Again, if you think about kind of what these lines represent, when I have a horizontal line, it happens to go through the y-axis at 3, or this point 0, 3. But it also goes through this point negative 2, 3, negative 5, 3, negative 462, 3, 4, 3 over here, 2, 3, 1, 3, 1/2, 3. It doesn't matter what the x value is. The y value is always 3. We end up with this line. Okay? And when I see this and I understand that, and I think about ordered pairs, I see a lot of errors about graphing this. People think you're just going to memorize it. When you have y equal to something, it's a horizontal line. Hey, if you remember that, that's great. But if I don't remember, or if I'm not sure, if I'm taking a test, I'm gonna draw a line, and then I'm going to test ordered pairs, see if it works. If I happen to make a mistake and did this, and I went this way and I went horizontally right here, well, one point right here which would be 3, 3 would work. This ordered pair 3, 3, if I put this line and said it's going to be a vertical line, and I check 3, 3, hey, that one works, great. But it's the only point that works in that case. If I go to this next one here, like 1, 3, well, what is my x value? Or excuse me, this would be 3, 3, 1. Sorry, I got ordered pair. It makes a difference, doesn't it, which order you go into. Well, 3, 1, this ordered pair 3, 1, I put that in there, right? I put 3 in for x and 1 in for y, and I get, well, I put 1 in for y and I get 1 equals 3. Hey, that point does not work. But if I follow this and I think about ordered pairs, and that's what they did, they took ordered pairs out of this. Does this always work? It says choose any x. It doesn't matter which x. If the y is 3, well, that's all I'm concerned about in this case. It is like putting 0 times x plus y equals 3. In fact, a lot of times when we take this kind of equation and say, well, it's 0 times the other variable, it makes you think of ordered pairs again, because that's what we're looking for, is ordered pairs in this graphing environment. Okay. Well, if I have x equal to something, now I'm going to have a vertical line, because this vertical line, the x value, stays the same all the time, in this case -4. And they give you rules about that and those kinds of things. I would still just get firm about how ordered pairs work and what solutions are, right? Get that drilled into your head. You really don't have to memorize any other things other than that. The rest of it comes kind of easy. And you remember that, hey, this is all ordered pairs that will work in some equation that they gave me. Okay? Then they get into rates. And in rate problems, rates are comparisons between two numbers. And that sounds like an ordered pair to me, right? And a rate comes from the word ratio. Ratio means fraction. And they're going to talk about this in change of rates and those kinds of things. There's a lot of applications have to do with rates and those kinds of things. And what's kind of different about a rate is a ratio, it's a fraction. Like in this website, it says it grows by 10,000 visitors over a period of 2 months. Well, the rate usually is the divisor of the fraction. In a rate, they want it to be 1. So what they do is they really reduce this fraction in a case like this, though that's not always the case. And I go, hey, that's the same as 5,000 per 1 month, and so on. If I go 150 miles in 3 hours, I go 50 miles in 1 hour. That's what miles per is a division. They should put a 1 here. Miles per 1 hour, right? And they should also do something different for m, because that's meters too. Okay. So caution, it says to calculate it's important to keep track of the units being used, and that's very important. If we think about like this stuff, car rental deal here, they're going to have a rate. They're going to say you're going to need to fill up doing this kind of stuff, and they're going to say, well, if I want to find out how many gallons of gas needed, 12 gallons of gas to fill up the gas tank, find the following rates. Kyle's, goes through all this kind of stuff. Well, when I end up with this fraction, they're going through that stuff, and that's important how they set up. I'm just not going to spend much time there. If I get 318 miles per 12 gallons, or divided by 12 gallons, I'm going to do the division of the numbers, right? 318 divided by 12. Do that on your calculator. You're going to get 26.5. What is that now? We still have miles over 1 gallon. So this is 26.5 miles per gallon, per 1 gallon, okay? And probably a good way to write it is just like that. We kind of see that a lot, or they put the word per, which means division, and so on. So rates have a divisor of 1, okay? They talk about these cautions. You should check those out. And visualizing rates, in other words, how do we draw pictures of these things? That's how we visualize stuff. So they're going to get into some graphing again on how do you graph these stuff. So they can draw graphs. You can set things up. You're going to look at your scale. You kind of want to set it up so the values that you actually have end up on that graph, right? And do that kind of stuff. Just kind of going back section, watching how you read them. Well, how do you make them is what they're doing now. These types of graphs. So those exercises. Now, here's where I see a lot of problem. So we found one in this very easy when you're graphing is you say, hey, I found a way to graph. I can use just ordered pairs. I put a table together. I substitute numbers in. I get the other number and I plot those on there and I end up with, hopefully 3 of them and they line up. So I got a graph of a line and I draw a line through that, right? They're going to go through some other methods or patterns that happen that hopefully you can see, and it'll help us graph more quickly in less steps. So it's a strategy really to make less errors. And some of these words that we run into, like rates we talked about, are all over the place. And slope is another one. When we have a slope or a hill, it's basically we're comparing the amount of rise that happens in the amount of horizontal distance that you move. I could say, like there's a big difference between saying I'm going to climb, when you get into like southern Wyoming, and I'm saying I'm going to climb up 9,000 feet elevation. I'm going to do that, but there's some areas where it's plateaued up there about 9,000 feet. And you're going like, if you make that drive there, you hardly even notice that you're going up in elevation. You'd start out probably about 2,000 or 3,000 feet elevation, drive for, maybe a couple hundred miles, and it's going like, boy, it's weird. There's so much more snow here or something, right? But now you could be almost at 9,000 feet elevation. It's not like you're on a peak of a mountain. Mountain climbers don't go there to say they climbed up to 9,000 feet elevation, because it's just this gradual, very little slope to it, right? Where if you go to Mount Everest, right, they go up several miles in a short horizontal distance. The vertical is extreme compared to the amount of horizontal. So that comparison they're talking about is called a slope. And they define what that is, which is rise over run. The amount of change over a vertical change, up and down change, compared to how much change you're going left or right. Okay? And so they go back, going through some graphs that hopefully you're familiar with, and they start introducing this idea, this relationship as a fraction. That was rates, right? And one of the rates that we're going to use over and over and over is called slope. And here's where they define that. The slope of a line containing the points. Now, this throws a lot of people here when they're looking at this for the first time. And why do they put these little number ones here? Well, because we're talking about subtraction or differences, order matters. We cannot change the order of a subtraction and get the same values. So it's important to know which one is which point. That's what they're doing here. X sub 1 and Y sub 1 are 0.1. And then the X sub 2 and Y sub 2 are 0.2. And the reason they got to be very specific about that is that when we do these subtractions, if I say I'm going to take 0.2 minus 0.1, I got to do it both for my Y values and my X values the same way, or I'm going to get an improper slope in a sense. So slope, which they use this letter M a lot for, is the change in Y, right? The change or the differences in the Y coordinates will tell me the change in the Y, the change in the up and down, okay? And over the change in X, which is this change left to right, right? So when I go from this point to this point, I go up this much, that's a change in rise, and I go over this much, that's a change in run. Rise over run. Here's how you do it with the coordinates. It's the difference of the Y coordinates over the difference of the X coordinates. Difference means the answer to a subtraction. Well, here they do it with some points and they get slopes. Now, slope is something we talk about. You see slope basically in the mountains when you're driving. In the highway, they talk about slope in a way where they call it different things, and that's something you can look up. In fact, I can't remember what it's called. Grade. They call it grade. And they're warning trucks if they have a heavy load on there, they're going to have some issues going, especially going downhill. If they have a lot of load in there, they need to get slow enough or into a low enough gear so they don't have to use their brakes too much if they have a real high percent grade. And they go use percents, which is just a ratio too, and but they could use slope. I wish they would have used slope. It would have made a lot less words for the same things, but in the English language we seem to like to have a lot of words for the same stuff, so but not in math. And they're going to be very, in algebra we try to get real specific with our definitions. So here's a formula for slope. Slope equals the difference in the y coordinates over the difference of the x coordinates. And then they talk about here, you cannot change the order. That can be a real problem. You got to be careful with subtraction. It's one of the reasons I don't like subtraction. I would rather stay with addition, because then I can change the order if I want to, or it doesn't matter. Okay? And then they give us some stuff about more about strategies, which is a good read. They color the page and put a square around it or a rectangle around it. That means it's important. Okay? And then they're going to talk about horizontal and vertical lines, because there seems to be a lot of confusion about this. If I have, in this case, this horizontal line here, which could be y equals 4, and remember what slope is rise over run. Well, what is the rise? What's the change up and down from this point to this point? It's 0, right? There hasn't been any up or down. No movement up or down. So it's going to end up, if they do the slope formula, you're going to subtract these two y coordinates. 4 minus 4 is 0. And then the change, or the run, which is change in the horizontal movement, or left-right stuff, is a negative 3. This x coordinate minus this one, I end up with negative 5. Well, I get 0 over negative 5, which is 0. And that's what they're pointing out here. All horizontal lines have a slope of 0. There's 0 rise over any run that you do. So they talk about horizontal lines have a slope of 0. Well, what about vertical lines? Now if I take from this point to this point, right? This is a vertical line, so all the x values are negative 3, right? Doesn't matter what the y values are. Well, in this case, I could take, they do negative 2 to this 4, right? So negative 2 minus 4, which is negative 6. But the run over here, which is change left and right, which is the bottom number here in this fraction, is going to be 0. There's no change here. And when we divide by 0, that's undefined. You know, if you think about multiplication as multiple additions, division is multiple subtractions. So if I say 7 divided by 0, that means how many times can I subtract 0 from 7 to get to 0? It doesn't make any sense, does it? So they do a special amount of paper there showing us that those slopes are doing that. So here we got this tool slope, and we have this thing called intercepts, right? And they're going to bring these things together and called something called the slope intercept form, and they're going to point out a pattern really that happens with equations. So they're going through the slope again on what that means and those kinds of things. And so if I had a point, I knew a point that was a solution to this equation, I knew the slope, I could say, well, where's the next point? I'm going to use the slope. I said, if I have a slope of 1/2, that means I'm going to go up 1 and to the right 2 will give me my next point on that solution line. So if I had a point and a slope, I can graph. And that's what they're talking about. It says draw a line with slope 1/4 in this case, and the y-intercept is 0, 2. In other words, 0, 2 is one of the solutions to this equation. But I want a graph of all the solutions, which is going to be a line. It's a linear equation. So I plot 0, 4, 0, 2, excuse me. And then I use the slope to get the next point. I go up 1 and to the right 4, which is 1 over 4, right? And it gets me to the next point, in this case, which would be 4, 3. I could do it the other way too. I could go down 1, which is negative 1, over negative 4, which is the same as 1/4, negative 1 over negative 4. And guess what? I get to another point on this solution line. So with a point and a slope, I can graph, and that's an important concept to think about. Hey, and I can do it quickly. If I know those two things, I can go on there and I can make my graph pretty easily done, right? I take points are easy to graph. Slope tells me where do I travel to get to my next point on that solution line. So the next thing then I say, hey, if we get things in a certain form, forms are basically patterns that we see. If I have it in this form that y equals 2x plus 3 in this example, if I want to know what the y-intercept is, right, what is true? The x value is 0. So I put 0 in for x, and I get y equals 3. So 0, 3 is my y-intercept. In other words, this value right here that's added ends up telling me where it's going to cross the y-axis. The other thing that's really nice that happens about this is the number times the x value is my slope. Always is if it's in this form. And I could go into why that works that way and stuff, and they do that a little bit, but that's what's important to know, that that number times x is my slope. So now what I know when it's in this form, and I look at this, hey, here's a point, 0, 3, and here's the slope, 2, which I can write as 2 over 1. So I go to this point, 0, 3, I go up 2, rise over run, to the right 1, and I got my next point on that line, and I can graph. So just having in that form, you should be able to graph very easily. And that's what they're going to show us over and over here in the examples. When I rewrite this y equals negative, or 4/5 x minus x, 8, I know that 0, negative 8 is my y-intercept, or point. More important than that, it's a point on my solution line. And then the slope will tell me, when I got that one point, how to travel to the next point on that solution line. In this case, I would go up 4 and to the right 5, and I have my next point to graph. All they're doing in this lesson is asking for what's the slope and what's the y-intercept, okay? When I'm just kind of jumping ahead, hey, I can use that to graph. And that's what they're really getting to. Graphing using the slope-intercept form right here, and they talk through this very well. But in this case here, they have a y-intercept. For this equation, y equals 3/4 x plus 5. The y-intercept is 0, 5. So you plot this point right here, 0, 5. I use the slope, and I can say, well, 3 over 4, rise over run. A rise of 3 over a run of 4. Up 3 to the right 4, there's my next point. I can draw my solution line. And that's what they go through this. And then they're going to point out parallel lines, perpendicular lines. There's a relationship between those when you think about that. Parallel lines, if you think about that, how parallel lines are basically in geometry are two lines that don't ever intersect. In other words, the only way that's going to occur is that they have the same slope. Okay? And then the trickier one is what happens when you have intersecting lines. And they kind of show some pictures here. Is what they have is the negative reciprocal of the slopes. So if I have one slope times another slope, I get a -1 when I multiply those together. That means that those two lines make a right angle or perpendicular. That's what perpendicular means, is they come together at a 90-degree angle, or right angle is another word for it. Or these two lines are perpendicular. They make right angles. Okay. And then they go through the exercises. So the point slope and equations of lines, they're going to take this slope formula, and here's where they're going with this. Okay, we've gone with this idea that, hey, I can take an equation with two variables, I can just plot ordered pairs, come up with a line. Then they said, well, what if you know what one point is and a slope, which is this ratio rise to run? I can graph a line. And then what if you put it into this form, y equals mx plus b? You can pick out the pieces and very fast and easily get the y-intercept and the slope. Then I can graph. What if I have 2 points and I want to figure out what the equation is for this deal? Probably in real world this is probably used more, where we're going to find out an experiment and say, hey, I do this and I get this relationship, and I do this again and I do more of these and I get a different number, and I start seeing that the relationship between these two numbers, or that ratio basically, or that pattern of ordered pairs, looks linear. It's creating a linear equation. I wonder what that equation is. So they're going to take the point slope form and kind of create that from that, or the slope intercept form, and kind of build it into using the slope formula. You could say, well, I can take these 2 points and find out, or take 1 point and a slope, which is this 1 point, and then I know that there's going to be a relationship for the next point, and I can create equations that way. So they have this point slope form. Says it kind of looks kind of like they got the y coordinates here, y minus the y sub 1 equals the slope times the difference of the x coordinates, x minus the x sub 1. There's that sub stuff again, but you got to make sure you're illustrating different points. So if I have a point and I know the slope, I can put the pieces into this equation in a sense. In this case, I know that I have this point 3, negative 4. So I can put that into these values, and I put in 3 for x, and I end up here with x minus this x sub 1, or x minus 3. And I could take the y coordinate, negative 4, which would be y minus negative 4, which is the same as y plus 4. And I end up with this thing. The quantity y plus 4 equals the slope, they told us too, is a negative 1/2. I can come out of this with an equation. And, I could graph the points easily. But what I'm trying to do is, what is the equation that would make all these solutions on this line? So they end up here. I can do some things like distribute this multiplication to negative 1/2 and do some stuff, and probably try to get it in the point, the slope intercept form. That's probably the most common way we're going to illustrate linear equations. Okay? And that's what they go through here to do that, and you end up with y equals something like this. So in this case, finding the equation line given a slope and the y-intercept. If I have a y-intercept and a slope, if I know it's a y-intercept, I'm not going to go through that point slope form. I know this form right here, which is y equals mx. The m is my slope. The b is my y-intercept, right? It's the y coordinate of my y-intercept. So if they give me a point and they tell me that this is where, or if it starts with 0, they're telling me that this crosses the y-axis, right? So I'm not going to go through all that point slope form and go through that. You could, but it's going to take a lot more steps, a lot more chances for error, and you're going to take more time, make more mistakes. Not a good strategy. So when I see this pattern, or if they tell me these two things, I'm going to go right to the point, to the slope intercept form. So in this case, it says find an equation for the line parallel. Parallel means that they're going to have the same slope. For this line, which is this equation, and then they're telling us the other y-intercept for this new equation is right here. Well, I need to figure out what the slope of this equation is, and one way to do that is to solve for y. When I get y equals some number times x plus some number, I know the slope. I don't even care what this number is. So they solve for y. And they go through this and they say, well, I need to take 1/8 times both sides, and I'm going to get y equals 7/8 x minus 3. But I don't even care about the minus 3. All I'm doing to do this is to get the slope of this equation because it's parallel to the line I'm trying to find. Well, I find out it's 7/8. So my new line has to have a slope of 7/8. And here's my y-intercept. I just put in the values into the slope-intercept form. Y equals, hey, the slope is 7/8 times x minus 6 because the y-intercept is 0, -6. The next type, they're given a slope and a point, or given 2 points, I'm going to have to use some other things. Okay? So they're going through some strategies. We basically have all the tools. Now it's about applying the right tool. In this case, they're using that point slope form and so on. And then you want to choose your best techniques to do that. Okay? And then they go through some apps and probably a long enough video. The other thing too, I've noticed going through the quizzes, I'm starting to do that. I'll try to get through most of the quizzes. I'm a little bit behind right now, but I like to go through the quizzes and the tests and see if you're having, if you're really close, it looks like you have the concept or you just didn't answer it correctly. Like if they want like 2 for an answer and you put in there x equals 2, it's going to count that wrong. So I'll try to get through those. But also it seems like a lot of you students are missing right now is that you get 3 attempts at those quizzes. And you have multiple days to do these quizzes in. And so a strategy here to do that, because quizzes are 30% of your grade. And what I'm hoping that you'll do is to attempt the quiz like it's a test. So don't use the book, don't use any resources that you're not going to be able to use on the test. And on the test, all you get is scratch paper and and a calculator when it's proctored by somebody. So they're going to make sure that you're not using any resources, right? Other resources. So try it that way. With the quiz, you're going to try it. It's very easy to do homework and other problems. You might have somebody, a friend, or you're in a tutor center or those kinds of things where you're getting help with pieces, which is good. You may not realize after a while how much help you're getting on some types of problems. When you try to attempt it on your own, you find out you're stuck. And, well, the quiz can help you recognize those. But then you have time. You can review that, say, oh, here's this type of question here. I got this wrong again. I seem to have trouble with this. Go back, look at the material, everything else. And there truly is something when you attempt a problem, even if you fail, and then go back and look at it again, you go, oh yeah, you're gonna get that aha moment, which is a great learning moment for you, in the sense that you can say, oh, I'm missing usually this one small piece you don't have in your problem solving skills, right? So that process. So you take the first quiz, you get 50%. Hopefully it's not that low, but 50%. You're going like, wow, I'm not going to pass this class. Well, you use that, you go back, and you're going to find out, you're going to go, oh, I just did simple stuff like I put x equals 2, they just want 2. So it got it counted wrong. I wouldn't worry too much about that stuff. Like I said, I'll try to catch those. You sure save me a lot of time if you don't do that. But you go through, but if it is something, you're going like, man, I don't know what I got wrong here. I think it's 3 and they're saying it's 7, right? It'll tell you what it's supposed to be. Go back, look it over, figure it out hopefully, then try the quiz again. This time you get 75% on your quiz. Go back through that 25% that you didn't get. Look at that, try to straighten out any issues you have there. Then take it a third time, and if you get 95% or 100%, that's what goes in the grade book. But I'm seeing some students here only taking one attempt at the quiz. I can't figure that out. I mean, I just go like, you have 2 days on a couple of these quizzes to do the quizzes. You know, it opens up, and it's open for the amount of attempts that I allow. And I think I even up the amount of quiz attempts on chapter 3 because there is a lot of stuff here, and it's pretty important that you get it. I think I gave 5 attempts. I think you have like 3 days or 4 days of time that you can work on this quiz. And so do it that way. I think you're going to have the most success. This part right here I hit here is the study summary for the chapter. It covers everything in real concise, condensed form. It's a pretty good study to go through that and look at this stuff. You know, attempt the quiz on your own. This might be a place when you go like, hey, I'm missing something. Look at this deal. You could probably, without having to page through the book, probably find out what you're missing, and then attempt again. Like I said, get your attempts in. Why not take all your attempts? We're talking about, you know, maybe half hour, 45 minutes of your time at each attempt, and it's well worth your time, and it's well worth your grade to get a high score on these things. So now this review, all I'm giving is quizzes. When we start chapter 4, which we're going to start this week, the process is we're going to have homework, then I'm going to have a quiz, and then we're going to have our first chapter test, which is also why I want you to attempt these quizzes like they're tests to get a good feel for where you're at. If you're in over your head on some of this review material or those kinds of things, you might want to be thinking about making a change, those kinds of things, rather than getting a little further down the line, because it's going to be a while before we get to the end of chapter 4 and take a proctored test. And I see students a lot of times, you know, they're going like, it's not that big a deal, or I'll treat my quizzes like they're homework and get through this. I'm looking, my grades are okay, and then they take that first chapter test and bomb. And that's 90 or 60% of your grade, so that's a big deal, right? 10% for homework, 30% for quizzes. But those chapter tests, it doesn't matter. We could have 1,000 quizzes, 1,000 homework assignments, and one chapter test. 60% of your grade for the quarter will be on that one chapter test. We're going to have more than one chapter test, but I can't emphasize that amount. Some people got accumulated points or how many problems you do. In a weighted environment like this, it doesn't matter how many quizzes I give, how many homework assignments. If we get 4 chapter tests done, those 4 tests represent 60% of your overall quarter grade. And like I said, they're proctored. It's not going to be something you're going to be able to use outside resources on. So practice doing it without, so you're prepared for that. Now, kind of long video, but hopefully this helps. I've been getting some questions, and hopefully it helps. A lot of other resources out there, use them. Tutoring centers open all the time in Wenatchee Valley campus, and the student library and the second floor upstairs. There's tutors available. They understand this. There are other students that have been through this. They understand my math labs usually very well, the ones that can help with math. So good luck, and we'll get started on chapter 4 here pretty soon.